All right, everybody. So here we got Algebra 2, Unit 2, Lesson 5. Even though it say Lesson 5, it's really the first lesson in Unit 2, okay? All right, so in terms of this lesson, what we're trying to do is learn how to factor. Specifically, we're going to have factor out a GCF, greatest common factor, and learn how to factor a difference of squares, okay? So we're going to go through both those concepts here today with you. Make sure that obviously you go back, you complete the Desmos activity, and that you're working on that Delta Math activity as well, and also obviously doing the exit tickets and the quest like normal, okay? All right, let's get started. So when we're going to factor out a greatest common factor, okay, the greatest common factor is going to be that largest monomial, meaning that one term. It divides evenly into every term, okay, of the polynomial. So here it says, find the GCF of 18x to the 6th minus 6x to the 5th plus 12x squared, okay? So there are two parts to a GCF, the number part, which is the coefficient, okay, and the variable part, so obviously the part with the letter. Okay, so to find the number part, find the biggest number that divides evenly, with meaning no remainder, meaning if we were to divide it, we would never get a decimal, okay, into every term of the polynomial. So here we see 18, 6, negative 6, and 12, okay? Now, we could divide those all, and we want to, right? We could divide them by 2, but then that would just be a CF, or a common factor. We want the greatest common factor. So the biggest number divides into 18, 6, and 12 is 6. So we're going to put a 6 there, okay? All right, so next, we would then want to determine the variable part. So what we want is the biggest exponent that's common to every term of the polynomial, okay? So here I have x to the 6th, here I have x to the 5th, here I have x squared. So I want to take out the biggest amount they all have in common. Well, the biggest amount they all have in common is to the 2nd, x squared. So that's what my GCF is going to be, is to x squared. So now my next step is I'm going to take the 6x squared and I'm going to write it as my first term on the outside. And then I'm going to form a parenthesis. Now I need to divide every term by that GCF. So I'm going to do 18 divided by 6, which gives me 3. Then I'm going to do x to the 6th over x squared. Remember from Algebra 1, when we're asked to divide with exponents, we actually subtract them. So 6 over 2 is going to give me x to the 4th. Okay? Then I'm going to do negative 6 divided by 6, which really is negative 1. Now we only need to put that negative 1 if everything else would cancel out. So right now I'm just going to put a minus, and I can go back to it and put a 1 if the x's were to cancel. But here you see we have x to the 5th over x squared. So when we're asked to divide, we subtract. So 5 minus 2 just gives me x to the 3rd. So I didn't need to put the 1. It's not wrong if you put minus 1, x to the 3rd there, you just don't need it. Okay? All right, next we've got 12 divided by 6, which is 2. And then x squared over x squared. Well, those are just going to cancel, so there's nothing else to do there. So that's kind of how that would look. Okay? Now, sometimes you're not asked to do this entire process. Notice here it says the GCF of. So all we're asked to do here for these questions is determine the GCF, okay? All right, so here the GCF of 6x squared plus 14x minus 8. So what's that GCF? Well, they can't have an x because the 8 doesn't have an x, so they don't have an x in common. They're all even, so we could divide by 2. Now we want to see, is there a bigger number that divides into it? Well, what else divides into 6? 3. Well, 3 doesn't divide into 14. 6 doesn't divide into 14. So that GCF would just be a 2. So again, that's kind of the process. So let's look at B. Here, I know that this is just an implied 1 in front of this x to the 4th. So I'm not going to take out a variable term. Or sorry, I'm not going to take out a coefficient term there, okay? So instead, I'm just looking for that variable with the exponent. So I see x to the 4th, x to the 3rd, and x squared. So I want to take out the biggest amount they all share, which would be x squared. So I'm going to divide by x squared, okay? All right, next. Here I see 3x to the 3rd minus 12x, okay? Well, I can divide 3 into both 3 and 12, so I'm going to use that. And then they do have a variable in common. They both have x. Now I can only take out x to the 1st because that's all that the 12 has. So my GCF there would just be 3x. Okay, last but not least, this really should be the easiest one, but sometimes people get tripped up by it. The GCF of x squared plus 7x minus 9. So I can't take out anything other than a 1 for the number because there's an implied 1 in front of this x squared. And I can't do anything with the variable because the 9 doesn't have a variable. So you can do one of two things. You can just write 1, although we wouldn't normally see that. normally what we just say is there is no GCF. And if you're asked to actually do this problem, you would just circle it. Okay, so now let's show how to do the entire process with these other three questions, okay? All right, so to switch colors of emphasis, I said that 2 was my GCF here, so I'm going to divide by 2. So now I'm going to write 2, and I divide each term by 2. So 6x squared divided by 2 is 3x squared. 14x divided by 2 is 7x. Negative 8 divided by 2 is negative 4. And then there we go, okay? Okay, here I'm going to divide by 3x. So 3 divided by 3 obviously is 1. You don't need to write that because x to the third divided by x is x squared. Negative 12x divided by 3x, well negative 12 divided by 3 is negative 4, and the x's cancel. We actually could do more here, but we'll see that in just a second when we learn about factoring a difference of squares. Alright, and then the last of the ones to do here would be to divide by the x squared. So x to the fourth divided by x squared is x squared. 5x to the third divided by x squared is 5x. Negative 3x squared divided by x squared is negative 3. And then there we go. Okay? Alright, so that's what that should look like for that. So this is called factoring out a GCF. Now technically you should be looking for a GCF all the time. Now lots of times there isn't a GCF, and that's fine, then we don't have to do anything with it. However, if there's a GCF, you should factor it out. Okay? Alright, so that being said, let's look at our other process here. Which is factoring a difference of squares, okay? All right, so let's pay attention to the key things here. First off, a difference. So it has to be subtraction. So if we see something like this, that's addition. We cannot do that. We would write that as prime, okay? So you cannot factor what it would be called a sum of squares. It's a difference of squares. I'll explain that in a second, okay? So here's your process, okay? If we had a plus b times a minus b, and we were to go through and double distribute it to everything, and get a squared minus ab plus ab minus b squared, well, minus ab and plus ab would cancel, so we'd be left with a squared minus b squared. So what this means in reverse is a squared minus b squared would factor into a plus b, a minus b. So let's go through what that actually means in terms of applying it practically. First off, both terms must be perfect squares. So to review back from what that means for us, if we have a number, that number needs to be a perfect square. So for instance, 9 is a perfect square because 3 times 3 is 9, okay? And then for a variable, that exponent needs to be even to be a perfect square. So it could be divided by 2 evenly. So in this case, 25 is a perfect square because the square root of 25 is 5. X squared is a perfect square because 2 divided by 2 is just 1. And then 49 is a perfect square. Square root of 49 is 7. So 5x minus 7. And then notice here you have a plus b, a minus b. So whichever way you write this, you would write it the other way for the second term. Okay? Now technically it doesn't matter. If I want to put the 5x plus 7 first, then the 5x minus 7 second, that would be fine. We could do that. Okay? Alright, so let's show this a couple more times. So here you see x squared minus 4. So again, x squared is a perfect square because the square root of x squared is x. Square root of 4, well, square root of 4 is 2. So I'm going to write x plus 2. Well, then I need to write the other one, which is going to give me x minus 2. Okay? So those would be our two terms. Okay, let's go here. So 16 is a perfect square. So 16 is 4. Y to the 6. So again, remember we're dividing that by 2. So we divide 6 by 2, we get 3. So y to the third minus, well the square root of 9 is 3x, because 2 divided by 2 is x, well, it's just 1. Okay, now we do the exact same thing, but with the opposite sign. Alright, and then this last one here is probably the best one. If you can do one like C, it means you included the first part of what we did, the GCF, and the second part of what we did here, the factor of difference of squares. So I see 3x to the third minus 75x. So actually, right away we go, well, those aren't perfect squares, which is true, but they do have a GCF, right? So we could divide both of these by 3, and they have an x that we could take out. So we take out 3x, and now when we divide, x to the third divided by x is x squared. Negative 75 divided by 3 is negative 25. Well, now you'll notice I've got x squared minus 25. Well, that's a difference of squares, so we could factor that. So you keep bringing the 3x down, and then you go, square root of x squared is x, square root of 25 is 5, and then I do the same thing with the opposite side. So if you can do C, I mean, that really does involve both the GCF part we showed first and the difference of squares part we showed here. All right, so that's factoring a GCF and a difference of squares and both. Hope this helps.